So we have these inequalities systems, and we want to see, we have graphs. We're going to see which one, we're going to match each one of these to one of these graphs. Let's look, for example, at number 4. So x is less than 5. Let me actually grab a pen. I have the luxury of writing on the book like this. Convenience. So let's do number 4. Basically, the first one says x less than 5. So x5 will be here. So the line is basically this one. It's a vertical line. That's what the x less than 5.
Less than 5.
So that line, the first one, is here, less than 5. So x less than 5. So this line is vertical. First, you draw the line, x equals 5. Then, to which direction do you go to get numbers that are less than 5?
You got to move to the left to go negative, right?
That's right. So x less than 5. So any number to the right, of the line should be actually, let me redo the line. Line should be dashed. We don't have or equal to. So the line will not be solid. If you have this, the line will be solid like this. But it's not solid because it's just less than. So instead I'm going to use a dashed line like this, or a broken line. So this is the inequality, x less than 5. So again, first you want to do the line. So if it's x, the line is like this. If it's y, the line will be horizontal. Then x less than 5. So any number to the left of that line, to the left of that broken line, basically is that inequality. This is the inequality. Then we do the other one. Let's do this in a different color. So this time y is -3. So if x is vertical, y will be horizontal. So y will be, y -3 will be somewhere here. Right, so this is a line, it's also broken. Okay, so it's a broken line. Now we want the numbers, or we want y that's higher than -3. This is y -3, it's a vertical line. It's a broken line because we don't have what equal to. If we had what equal to, this would be solid, but it's a broken line. Now, if you want the y's that are higher than -3, where do you go on this line? Do you go up or down?
You go up.
That's right, so we're gonna shade this up. So basically the solutions here is where the two shades overlap. So where do the two shades overlap here?
In D, the graph that's D, because it has the dash.
The D, okay, let's see. Because it has a dash. This one looks kind of similar, but it doesn't have a dashed line,
It's
right?
solid, yeah.
Right, so
Exactly. So let's scroll down. So it will be this one.
yeah, D.
Exactly.
the right
Broken line.
right?
Might look like this, but because of the dashed line, this is it. So basically, these two overlap here, as I did here. Let me use, if I use a different color now, so those basically, you can say they meet here. So this intersection. Okay, so this is this quadrant. It's basically where the two, or the green and orange and red overlap. So the solution to this system is where the two overlap. So this system here, which basically kind of write like this. System of two linear inequalities. So basically we graph both and see when they where they overlap. And the intersection of the two is the solution. Just like we saw before with the lines, if we have just lines instead of inequalities, so the solution was the intersection of the two. Same thing with inequalities. So these were equations because they had equal signs. these are inequalities because they have less than or greater than. So for the lines, the point of intersection or where the two lines overlap is a solution. But for inequalities, that's where the two shades overlap. So that's the solution to this system. So this quadrant here. So that's the solution of this system. Same way you can match any other ones. Let's look at number 2. All right, let's see which graph matches. Which graph matches 2? So x, we have 5 and -3. How are the lines, by the way? Are they solid or broken?
Solid.
They're both solid. So we ignore any line that's broken. For example, ignore this. Ignore the one we just did. It's already out. Now we have just 2 left. We have this one. So x, what is it? So this one. So x less than or equal to 5. Does it match this graph? I mean, we're doing number 2, yeah. For the inequality x less than 5.
Is it A?
It should be A, because less than 5 will be to the left, and y greater than or equal to -2 will be up. So the 2 meet over here. So this one matches that.
That was number 2, right?
This was number 2, yeah. This one
Okay.
right here matches that. And same way, so basically the other 2, the odd ones, that's what you're doing for the homework.
Yes.
Okay, so that's basically some linear inequalities. So you graph both inequalities, you shade both, and then see where the 2 shades overlap. That will be the solution. All right, that's 4.5. Okay, so the unit 4.5, and those are the problems. Any questions, everybody? Santiago, Ayana, Diadra.
No.
No, different. But let me make an example similar to question 6. So this is from the old book.
Do you want me to read you the A, B, C, and D?
That's all right, I got it.
Okay.
So from my understanding, we have to match. So rises from left to right. The line falls from left to right. And then we have the lines are parallel. But actually the line is vertical. And the
Horizontal, and the other one's vertical.
Okay, so the other line is horizontal. Something like this. So that's all of the 4 possible lines you may see. So linear equations could either be rising from left to right, could be falling down, as in here. The line could be vertical, or in this case, it's x equals something. When the line is vertical, it's x equals a value, for example, a. And when the line is vertical, horizontal, the equation of the line is y and some number, some constant, b. Could be positive or could be negative down here. And let me give you some options for a, b, for the slopes. So a, let's say, a is let's say negative number, b, a positive number, let's say 5/7, c, maybe 0, and d, undefined. Okay, so we have 4 lines. These are the slopes. Choose or match graphs with the following slopes. Something along those lines, right?
Yes.
Okay. With these, just say with these slopes. each one of these represents a value for the slope. The value is negative, the value is positive, the value here is 0, and D finally is undefined. So each one matches exactly only one of these. So again, when the line rises from the left to the right, what's the sign of the slope? When the line rises from the left to the right, the sign of the slope is?
Positive?
That's right, it is positive.
Oh.
So which answer matches this? Which one of
C?
these values matches the graph?
B?
Say that again?
C?
No, so
5 over
instead,
7, B.
that's right, the B. So B is, the only positive number here is this.
Oh.
And since the slope rises from left to right, that means the slope is positive. What about this one? It's the opposite of this. What's the sign of this slope?
A? That's a negative?
A.
That's right. So this is a negative
Oh,
slope. So
no.
that matches the only negative number we have, which is A.
Okay.
Okay, these are a couple of special ones here. When the line is vertical, what do you say about the slope? Only options left. So this one is done. This one is done. It's got to be one of these.
Undefined.
That's right. So whenever the line is vertical, there is no slope. It's undefined. Okay, it's an undefined slope. And if the line is horizontal, the only option left is the slope will be,
C. 0.
that's right, will be C.
Horizontal.
Exactly. So remember, these are all lines. If you see this, you can easily tell the sign or the value. In this case, the value, if it exists, of the slope. You don't need to find the slope. You just need to say or to match the graphs with the sign or the values. We'll give you the values. Since we know the signs, we can match them easily. So again, this one is positive. The only positive value is this. This one is negative. The only negative is 1. And when the line is vertical, the slope is undefined. It doesn't exist, or it's basically undefined. It's not 0, it's undefined. The reason why it's undefined because the slope formula has x minus x in the denominator. And for this line, the x is the same. For example, if x here is 2, so when you divide the slope formula, which has x minus x at the bottom, when you do the slope formula like this, y2 minus y1, so we need 2 points. So if you take any 2 points from here, this value, this will be the same because the x here is constant, is 2. So any two numbers here will have the same x. And if you subtract the x, in this case 2 minus 2 will be 0, and division by 0 is undefined. That's why if the line is vertical, the slope is undefined. But if the line is horizontal, the y will be the same. For example, 3 here. If you subtract 2 y's, the y is here for any points on this line, the y will be the same. If you subtract these, you will have 0 here, which is fine. 0 over anything will be over any number other than 0 will be 0. But if the line is vertical, you end up with 0 here, which makes it undefined. You don't have to remember that explanation or that reasoning. Just remember, vertical line, undefined slope. Horizontal line, the slope is 0. Okay, everybody?
Okay.
You guys understand that?
Yes, I
Yeah.
understand. Professor.
Yes.
Yeah. Thank you.
No problem.
Yeah.
That's question 6. Similar. I changed the values, but it can do the other one in the same way.